This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at javascriptjabber.com/KendoUI. Hey everybody, and welcome to another episode of JavaScript Jabber. This week on our panel we have Aimee Knight.
Hello from Nashville.
Cory House.
Hello from Kansas City.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that's Ben Titzer. Did I say that right?
Titzer. Hi. Hello from Munich.
Munich. That's a long ways away.
It's very far away, yes.
Yeah. So do you want to introduce yourself? Let us know who you are, why everybody loves you.
I don't know if people love me, but I can tell you who I am, or who I think I am. So I'm a JavaScript VM engineer here in Munich. I work on the V8 team. That's the JavaScript engine in Chrome, as everybody knows. I was one of the co-inventors of WebAssembly. I started the project back in late 2014 with Luke Wagner at Mozilla. And since then, it's grown to include people, dozens of people at Google and at other companies, at Microsoft, Mozilla, and Apple. And it's been shipped in 4 browsers, and it's now becoming a W3C standard. And now I pretty much do VM engineering for WebAssembly and also work on standards bodies things for WebAssembly.
Nice. And the whole WebAssembly thing is so exciting, at least to me, because I've worked in a number of different languages, some of which I like better than JavaScript. And so the WebAssembly, as far as just being a compilation target, is exciting to me because maybe I can write code on the front end with some of the languages I like on the back end.
That's our hope too.
I was wondering if before we get started, you can kind of give us a little bit of a history lesson and talk about the difference between Wasm or WebAssembly and ASM and how ASM came about and kind of paint the conversation going forward a little bit.
Sure. So I can give you my perspective on this history. So I joined V8 about 5 years ago. That was in 2013. I actually moved specifically to Munich to work on V8 with the V8 team here. And about mid of that year, asm.js came out. And asm.js was a compilation target for C++. It was a Mozilla project. I grew out of Emscripten. Emscripten had targeted JavaScript by compiling C++ to JavaScript, but there wasn't a particular subset that they were targeting. It was basically just working with vanilla JavaScript. But the Mozilla teams came up with asm.js as a compilation target. It's basically a subset that has sort of kind of ceremony around the type system. If you validate asm.js code by looking at the types that are embedded in the code, then it's easy to generate very fast machine code for it. And that's the approach that Mozilla took. When I joined the project, the V8 project, basically the idea was to build a new JIT compiler for JavaScript. And one of the things that was clear that was going to become very challenging to make fast was asm.js using the previous techniques. So what we did was we started building a JIT compiler to make asm.js fast. So we did that through a number of compiler analyses. We did not actually implement the asm.js specification as it was. But the idea was that we would be able to reuse the compilation optimizations techniques that we had for asm.js for regular JavaScript, and it would kind of all be a nice, big, if not complicated, JIT compiler inside. By the time that we got the first version of what we call TurboFan now out for asm.js, it became clear that asm.js was not the perfect compilation target. So I started having conversations with Luke. We had VCs much like this, a couple of times, maybe once a month. And the idea of developing a bytecode for the web came up. And we thought that the asm.js use case was compelling enough that we should have a custom design solution for it. And Luke, I think, came up with the idea for WebAssembly, or somebody in Mozilla did. I remember when he came back to me with the name, and I thought, that sounds pretty cool. In the beginning, we were calling it WebAssembly, but the BASM it kind of has a funny feel to it. It's like spasm. So WebAssembly became a little bit more acceptable, palatable way to refer to it. And by about, I would say, March of 2015, other people inside of Google, in particular the Knackle and Pinnacle teams, they got involved. They saw that this was a potential for multiple browsers to collaborate. So NACL was a sandboxing technology for x86 code that was developed at Google. That was shipped in Chrome, but they had troubles convincing other browsers that this was the way to go forward. And because it was x86 code, it was not portable. So there was a follow-on project called Pinnacle, or Portable NACL, that was basically same kind of idea, but using LLVM bitcode as their distribution format. There was also challenges in convincing other browsers that this was the way to go. But WebAssembly kind of started as this cross-browser collaboration. So I worked very closely with Luke for many months and many years to make this happen. After March 2015, we started talking to Apple and Microsoft. Microsoft actually implemented asm.js before. They were, I think, the second browser to implement asm.js, and they became interested in WebAssembly. So they were quite easy to bring on board. I talked to Phil Pislow at Apple, who's somebody I actually knew from school. He liked the idea, and with that, pretty much all 4 browsers were on board. At least engineers were. I don't know if the management was. It's always unclear when engineers start to hash out solutions whether that's going to fly with management. But it seemed to go pretty well. Everybody saw the need for it, and the rest is, as they say, is history. It was a long slog, but yeah, I think it worked out pretty well.
So I want to ask one more question, kind of it relates to this. Since we're on a JavaScript podcast, the stuff that kind of the community seems to be concerned about is the effect that this would have on like the JavaScript ecosystem. And you want to like maybe talk about some of the concerns people have and if you think they're valid or not?
Sure. So one of the things back in 2015 that we talked about a lot is what is the role of JavaScript? What is the role of WebAssembly? Are they complementary? Or do they step on each other's toes? Is one going to do violence to another? And it's actually a complicated question because on one hand, there was a proposal called SIMD.js, which was to add SIMD operations to JavaScript. This was very highly regarded by Intel and by Mozilla, but other browsers didn't think it was such a great idea.
Sorry, what's SIMD?
SIMD.js, single instruction multiple data, basically exposing 128-bit vector operations in JavaScript. So SIMD.js came out, was supported in Mozilla in Firefox, and we were considering support for it in Chrome. In fact, we developed a prototype in Chrome. Intel developed a prototype, but we started doing our own implementation. The idea was that we would support SIMD.js in TurboFan and that we would make SIMD.js fast. What we found is that when you get down to the amount of surface area that it adds to JavaScript, or SIMD.js did add to JavaScript, it was a lot of implementation. And it seemed like it actually was twisting JavaScript in a way that maybe wasn't good for JavaScript programmers because JavaScript was serving as a compilation target. Now, meanwhile, keep in mind that this is my perspective on this. Don't take this as gospel. But it definitely seemed like JavaScript serving as a compilation target pushed it in one evolutionary direction, which was not necessarily the same evolutionary direction you would want as a source language for people to develop it. So that seemed like maybe JavaScript wasn't the solution to the SIMD problem, whereas Wasm, which is designed as a compilation target, would be a better place to put that. In particular, so when we got into making SIMD.js fast, the sort of, I don't know if you know much about how JavaScript implementations work, but there's typically a fast path and a slow path. And you have to add certain types of checks to guard that you're on the fast path. And the amount of checks that you need to add and the amount of things that have to go right for SIMD.js code to get as fast as it could possibly be was actually pretty enormous. And it was mostly, that's kind of fallout of JavaScript being an untyped language or a dynamically typed language. So what we found is that it was much easier to add SIMD to a statically typed language by design, which is Wasm, than it would be to add it to JavaScript. So I think I would claim that adding SIMD to Wasm saved JavaScript from the violence that would have been done to it by SIMD.js. Other people would claim differently, but that's my personal opinion. So it gave the two languages the freedom to evolve in the ways that meet their community's interests best. So I think that's actually a win for both of them. So that's my view.
It seems reasonable from what you're saying.
So one thing is Wasm has int64, and people have talked about adding int64 to JavaScript and how to do it because JavaScript only has double numbers. And once you wander out of the 53-bit integer space into the double number space, then you end up with sort of weird results. And so it was really easy to add that. This is another case where it was really easy to add something to Wasm that was uncontroversial. Then we ran into a small impedance mismatch when we export 64-bit integers to JavaScript. And what we chose at the time when we standardized WebAssembly, the integration with JavaScript for the first version, is basically 64-bit ints on that boundary are just not allowed. And instead, we opened it up for future evolution. And then later, that actually allowed the JavaScript community in TC39 to work on BigInt. So a different conversation with people who are interested in JavaScript happened with BigInt, and they settled on that solution as opposed to adding 64-bit in to JavaScript. And now we actually have the ability that we can export 64-bit ints from Wasm to JavaScript and they're reflected as BigInts. So I think that actually kind of worked out pretty well.
One concern that I've heard is that JavaScript benefits a lot from being the compile target for a lot of these compiled languages like TypeScript and things like that. And if they compile to Wasm instead, then a lot of the focus will move to that, and JavaScript won't get a lot of the goodness that it's gotten to date. Is that really a concern that we need to be worried about, or will JavaScript benefit from a lot of that because it'll compile to Wasm as well?
That's hard to say. So it's definitely the case that inside of the engines, every WebAssembly implementation in a browser shares essentially all of the machinery with the JavaScript engine. So any particular feature that Wasm has, it's mostly a matter of exposing it through the language. Mm-hmm. So there's not something inherently more difficult or better about adding something to Wasm as how easily it can be expressed in the type system. As far as compiling to JavaScript, there's always an upside and a downside. The upside is that it's relatively easy to do because JavaScript doesn't have a type system that really enforces a model on you. Mm-hmm. It has like very flexible objects, so that's nice for people who compile their crazy languages. On the other hand, it doesn't give you all the performance that you could get from something which is statically typed. So there's been a proposal to add more to Wasm, to add what's so-called GC proposal or managed objects proposal for languages that currently compile to JavaScript but don't get the full performance or the full benefit out of that. So in particular, I have pretty good contacts with the Dart team. I talk to them relatively often. They're very excited about compiling to Wasm. They've been compiling to JavaScript for quite some time. And the funny history of that is the Dart team actually was the original V8 team, so they know how V8 works really, really well. So they can generate the perfect JavaScript to run on V8. I think there is a market for both types of compilation. I think dynamically typed languages compile to JavaScript just fine, no problem. They get the benefits of the dynamic optimization that the engine does underneath, and everybody's happy. But statically typed languages, they end up with overheads. So I also had contact with teams that compile Java to JavaScript, like Gwt, and the result is often very suboptimal. Mm-hmm. And I've heard the same from many other languages that maybe have a native implementation. So they have a pretty good idea of what their object model should look like at the machine. But when they compile to JavaScript, they have no control, and they end up in sort of a suboptimal performance regime because of that. So I think it basically boils down to, I mean, I don't want to oversimplify it, but it does boil down to how statically typed you are. The more statically typed you are, the more you're going to benefit from WebAssembly. And if you're not statically typed, then it probably doesn't benefit you. And that's okay.
Well, what about some of these languages like TypeScript? Because it's got annotations. It's not completely 100% statically typed.
Correct. My understanding is that TypeScript, even though it is statically typed and has annotations, it still has dynamically typed aspects to it.
Mm-hmm.
So you can still violate the type system in certain ways. I'm not plugged into the TypeScript community, so I couldn't say with authority what their plans are for compiling to WebAssembly, but it seems like it's something that they could do. We know for sure that C# is compiling to WebAssembly. They have basically ported Mono over to run on WebAssembly. There are Java groups that want to do that. The Dart team now is interested. So it's a slightly different crowd. I think TypeScript has this long history with JavaScript, and they're kind of coexistent in a way. There's like a synergy there.
Gotcha. Sorry, Cory, I didn't mean to talk over you. Go ahead.
No, we ended up asking the same question. So thanks, Chuck. Although I do have another one. So are we at a point yet where you see a lot of opportunity for people writing line of business applications, which are so common for JavaScript developers today in particular? How close are we to people thinking about using WebAssembly for at least portions of their applications? Is that a logical use case for this, or do you see WebAssembly as more niche toward more performance specific scenarios, like, for instance, gaming?
That's a good question. So it's really difficult to make predictions specifically about the future. I will say that the game type of application is something that we had in mind as kind of the first applications. Those are the forefront. They were the early adopters because they have this legacy code base, which is in C++. With Emscripten, they can flip a switch and, with some other doing on their part, but less doing than they would building a new application, they can run the web really fast. So those things have taken off. In just the year since that we shipped in stable, it's taken off incredibly fast. Now, the question is about the second generation of WebAssembly applications. So one thing that I see is that Rust is investing heavily in WebAssembly. They believe that this is just my personal opinion, so I'm not speaking for them, but they believe that their web strategy is all about WebAssembly. I find that to be very heartening, being a WebAssembly person. Rust is a cool language. It's got a lot of innovation. It's quite safe. So I think that is going to be the type of thing where new languages come through WebAssembly, particularly ones that are statically typed. As far as applications, we still have a few challenges to solve with integrating WebAssembly and JavaScript. So libraries between the two. So along with the games, there's another easy kind of application that we thought about, which is basically integrating a library, which is written in C++ or Rust and compiled to WebAssembly. And then now your application can move sort of incrementally, or you can use them as subroutines, like an image processing library or something like that. And then the core business stuff, to be honest, I'm not sure how that will play out. But I can definitely see that for certain types of languages, if the application were written in those languages, it could work.
So it's interesting. I mean, the short-term feature that you just described reminds me a bit of the way people are using Node today, where you see people, yes, you're using Node as the initial endpoint sitting behind something like Express or Happy or Koa, but then heavy lifting ends up happening in some other technology, some other language, often a strongly typed language. So people are effectively recognizing that they want power tools once they move far enough back on the server and back end processes and those sorts of things. And so it sounds like those will be the first places that people potentially consider reaching for something like WebAssembly instead. So I guess that's interesting too. I hadn't even considered, WebAssembly, with the name web, you obviously think about the web and browsers, but someone could just as easily choose to use WebAssembly instead of something like Node on the server at some point too, right?
Yeah. In fact, so we've been talking about what is Node's native strategy for integrating native modules. And so I'm not a Node developer, but so my understanding is that you basically recompile C++ source code on every server, right? So there's no sort of binary portability whatsoever. But we've talked to a couple of different people, and we have quite some people in Google that work on Node that have a good relationship with V8. And we've talked about how WebAssembly could factor into that story. There's a couple of different ways. Some of them are more workable than others. For example, you compile your C++ native part of your Node app and to a Wasm module, and then you just load that as a binary. But you still have to bind to the host. So we have to think about how, WebAssembly is without its imports, it's just a CPU, right? So we have to think about how WebAssembly would have sort of host bindings for that. That's one possible way. There are others.
Well, and I'm also wondering, this may be a silly question, but will it also make sense to have some kind of a package manager for WebAssembly for people to share code?
Yeah, that's a good question. I haven't thought about that. I don't think we're kind of building this thing bottom up, right? We built the CPU, we built the tools that generate code for the CPU and applications and libraries, and then package managers is probably the thing that's going to come as the next step.
So one thing that I'm wondering too, is WebAssembly going to be something that people can actually code in, or will it be sort of an obscure compilation target that's not readable on its own?
Well, so we had concerns about that throughout the process. So one thing that we did was make sure that we have a text format so that you could see WebAssembly code and at least eyeball it and read it, so it's not just bits. The text format is basically, it looks a little bit like Lisp code. So it's got like parentheses everywhere. It's all nested. I've written a fair bit of WebAssembly by hand, but I don't think that's very common experience. It's something that it's a bit like assembly language. People who write compilers will see it. People who are trying to reverse engineer applications or maybe work on performance of something at a very low level will see it. But it doesn't have a big market for people to write by hand, I think. Maybe you can obviously dynamically generate WebAssembly code if you stitch it together at runtime based on your applications. Your application, it basically becomes a JIT compiler. But I don't think it would be something that you would like take a university course in how to write code in WebAssembly by hand.
I don't know. I had to write some assembly in college. I had sadistic professors.
It's actually a lot of fun.
Yeah. Unroll the loop, remove the no-ops, do this and that. Yeah, it was usually performance stuff that we were figuring out and digging into how the processor worked with the different instructions. So that said, then, if people aren't really going to be writing much WebAssembly, I have to wonder then, to what level do people need to understand what WebAssembly is?
I think it's okay for most people to understand what it is at an abstract level, that it's the binary code that runs down there. We did think very carefully about making sure that the people who do have to understand it really do fully understand it. That's why in the specification we actually have formalism. There's actually a type system. The way WebAssembly code is validated is actually expressed as a type system. And it's actually very simple compared to, for example, people who worked on WebAssembly had backgrounds with Java virtual machines and Java bytecode. And those things are horribly complicated. There's lots of corner cases. So in WebAssembly, we made it absolutely clear what WebAssembly code should do. It's extremely deterministic. There's no wiggle room at all. And it's actually very simple. So, for example, you just have an if, and you execute an if, and it either goes here or there. So there's not a lot of like really tricky details in WebAssembly. That's kind of what you want in a standard, something that everybody really understands and can agree on exactly what it is, so that there's no drifting between implementations and compilers disagreeing. So in that sense, the people who do have to understand it, I think will understand it really well.
I would also argue too, I don't know, from like a less experienced or, I don't know, I still call myself new. whatever, junior dev for life thing. But like I would argue, like at least understanding this stuff, like you say, from a high level is beneficial for people who haven't, like for me, don't have a traditional computer science degree. Like understanding this stuff gives you an appreciation for, what JavaScript is doing. And then everybody likes to, laugh at JavaScript for some of like the different, cases where you type in a number and things don't add the way you expect it to add because they don't really have always a concept of like what's happening at a lower level.
I'm curious, once we get to the point where we're using WebAssembly, are we going to be loading WebAssembly files into our web pages instead of JavaScript files?
It's already happening.
Okay. So what does that look like? And how does debugging look like, if there's a problem on the front end? When you start a new project, typically you need things like a domain name, hosting, things like that. When I choose hosting, I pick mine for the options it gives. I like to know what I'm getting and set things up just how I like them. This is why, for your projects, you should check out Linode. Linode servers feature native SSD storage, a 40 gigabyte network, and Intel E5 processors. That's all the power you need to run VMs under full control, or Docker containers, who doesn't love that, encrypted disks, and VPNs. Plus, they have 10 data centers across the world and add-ons like backups, Node Balancer, and Longview to help you control your server costs. They also offer block storage for your static files, and you can get started with a $20 credit if you use the code JavaScript Jabber 2018. That credit is good for 4 months on their 1 gigabyte server. That's a lot of time to try them out and see if they're the right fit for you. That code again is JavaScript Jabber 2018. Also, if you're interested in working for Linode, they're hiring. Head to linode.com/careers to see their available positions.
So, this is the problem when you have a compilation target, because now you're far away from the source code. So the things that we've done so far is we've made it possible so that you can at least debug WebAssembly at the WebAssembly level. So you can see all the bytecodes, you can step through them, you can set breakpoints, you can see the numbers as they go by. You can inspect memory and things like that. But that's kind of like debugging at the machine level, the way you would do if you had a new machine that didn't have a compiler with source maps. So the next step is to go to source maps where you can map particular WebAssembly functions and bytecode offsets into line numbers. So that support is already there in Firefox. Chrome is coming along as well. But the step after that is being able to debug in your source language through WebAssembly. And so this is where we get into a design space that's not entirely understood yet. My personal view is that basically we'll have a JavaScript API, and JavaScript, just because it's the thing which binds all things on the web, it's like the force. But JavaScript API, where you can debug the WebAssembly machine and then translate that to your source language. So a source language compiler would come with this module, and that would plug into the debugger, so to speak, in the browser. And then now you can step through your Ruby or Rust source code and see your Ruby and Rust data structures and stacks and local variables and all of that. So hopefully, if we do it right, then WebAssembly will disappear into the background. You won't see it at all. It'll just be an implementation detail, and you'll just see your source language, and you'll just see it run on the browser, and you'll only see your source language objects and functions. That's kind of the holy grail, I think. It's going to take maybe a year or two before we get there. There's a lot of moving parts involved, and tool chains are, have quite diverse. But that's the vision that I have.
Hey, if we get to the Holy Grail in 1 or 2 years, that sounds pretty good. Yeah. I didn't actually hear you say the term source map. Maybe you did, but as you were describing the problem, that's instantly what popped into my head was today I'm writing in ES 2018, but I am compiling down to ES5 so that it runs everywhere. And how do I debug it in production? Well, I use a source map. And the only time that source map is downloaded is when I open the dev tools. And it strikes me that that same model could theoretically work for WebAssembly as well. It's just the source map would obviously be huge because the difference between the two languages would be vast, or between the source and the target, because when you compile down, it's very different. But is that basically the model that you were describing there? It sounded like
I would say source maps is basically step 1.5 on this continuum. So I think Mozilla already does have support for source maps for C++ on top of WebAssembly. And we're working on that now in Chrome so that that will work. So you can see source level C++ code and line numbers and things like that. I'm talking about the next step where you can interactively debug and you can poke and change values and all of that in any language. That's where I want.
Oh, wow! Yeah. So what I just described already exists and runs in Firefox.
Yeah.
But only if you wrote using C++.
Pretty much, as far as I understand. Yeah.
Okay, and that actually gets to my other question. I may have missed it earlier, but I didn't hear a list of languages that I can currently write in that compile down to WebAssembly. C++ is obviously one option. What others are out there right now?
You can do Rust. Mono has a prototype, so you can do C#. I think other than that, I actually don't have a good complete list. That's not. But yeah, I think there are more out there. There are people who are inventing languages for WebAssembly.
Yeah, the C# one I just heard of the other day because apparently Microsoft's pretty excited about really embracing this because it gives you so much power, and it's something that I would expect Microsoft is uniquely enabled to do quite well too. So
Yes.
I could see that going a long way for them. It's an area where I could see them having a sort of a competitive advantage. Although I still don't have a good sense of exactly what the revenue model becomes on this story, but with the new Microsoft, I think you chase the innovation and then you hope that the revenue model shows up later because they seem to have more of a startup mentality than they have in a long time. So I'm excited to see it.
I think Visual Studio is a great development environment. It'd be awesome if you could just debug your web app with Visual Studio and it was WebAssembly in the browser. Actually, I think that would be really cool.
So this makes me wonder then, we have, how do I put this? A lot of JavaScript's adoption has been that it is the language for the web. And with WebAssembly, this changes the equation some. I mean, as we get these implementations, C# or Ruby or Rust or some of the other languages that you've brought up, where they compile or can run a virtual machine on top of the browser stack using WebAssembly, do we see a refragmentation of web technologies back away from JavaScript? And the larger thing that I wonder is, does this affect node adoption on the back end? Do we see some people fall back to where they were before? Or I don't know. And this is mostly speculation anyway, so...
I don't know. So it can go. So I think JavaScript will always be natively supported on the web, just because doing for technical reasons and also for historical reasons. JavaScript will always kind of have a special place. Those other languages, I don't see. It's going to be chaos, honestly, for a while. But I think that if people work together, that we can make the whole story actually work. So avoiding the chaos is part of my job now, and part of the WebAssembly team in Munich and Mountain View. We have a big team over there. I can foresee that it could get really complicated and fragmented, as you say. But I also think there's a lot of opportunity for innovation there too. And in some sense, I've said this to many people, like as a platform. And as a compilation target, we can't be too opinionated. We're not in the middle of language wars. We're not going to take sides there. So I think there's going to be a lot of different languages that come, and it will be somewhat topsy-turvy for a while. But I don't think it'll be ultimately untenable.
The other thing that I'm wondering about is multi-language systems. So let's say that I'm into Angular or React or Vue, and I'm like, this stuff's awesome. And they have some kind of compiled to WebAssembly that they do. And I'm sitting here thinking, you know what? I really want to write my front end in Scheme with React. And Scheme also compiles to WebAssembly. So is there a way to kind of blend the worlds in a really heinous way so that I can actually do that?
Chuck, you're crossing the streams. Don't cross the streams.
I know, right?
Is there a way to do that currently? I don't know. There's interesting research that I can tell you about doing this in the Java ecosystem. So in particular, there's a system called Graal where they basically use Java as the base instead of JavaScript.
Mm-hmm.
And then you can write, for example, a Ruby interpreter, and they have a magic technology called partial evaluation to make that really fast. And you can do cross-language calls. And that all kind of works in the Graal ecosystem. And they have some really cool techniques there that maybe could be picked up in a future where I see people doing this for real on the web. So writing your React thing in Scheme and making it all work together, I think that's something that, yeah, it would be cool. I think we can make that work in 5 years. We'll take some time.
That's cool. I'm looking forward to the chaos. So is there anything else that's coming in WebAssembly that we need to be preparing for?
Sure. Yeah, there's kind of a host of small add-on features of various sizes. And then the big one is threads. So as you know, you guys probably have some experience with shared array buffer. But WebAssembly basically will give you worker-based threads. So you can spawn a new worker, you can send a WebAssembly module to that worker, you can instantiate the module over there, and then they can share memory. So that's the sort of nuts and bolts of making threads work. A lot of it also happens on the toolchain side for C++. The dream there is basically you can take a C++ application which uses pthreads and press a button, and out comes a web app that runs with threads. There's a lot of moving parts to that. We've got the sort of nuts and bolts of that mostly implemented. So atomic operations, which were all essentially lifted directly from shared array buffer, are now part of Wasm. And there will be a proposal to standardize that as a standard extension.
I kind of feel like I'm somebody in 1980 that's hearing about the concept of cell phones.
Yeah.
I'm going to take this C++ app and I'm going to make it work on the web without any changes. Just press a button. Sure.
Here, Joe, just tap on this piece of glass and it'll tell you where you are.
Yeah, I mean, the web always has lagged a bit behind desktop systems, shall we say, in technology. But we're getting there, yeah. The people involved are very cognizant of where we are on the technological curve. But yes, hopefully we can make this work.
So have we talked about adoption yet? You've mentioned some of the features that are in Firefox and possibly Chrome, but how much of this is implemented in these browsers? And yeah, how far do we think we're going to be, like, say, by the end of the year?
That's a good question. So I don't have and would not be able to speak for other browsers shipping schedules and roadmaps and things like that. But just based on contact with engineers, people are really excited to get threads through. I think SIMD is mostly non-controversial at this point. So there are actually 3 implementations of WebAssembly SIMD that basically just have to be lined up and standardized. The other smaller features are not controversial. Things like adding different kinds of conversions or adding tail calls or adding, for example, those kinds of things. Those are smaller additions. For Apple, they have a pretty rapid release schedule, which is slower than Chrome. And Microsoft has a much slower release schedule. So it may be that it takes multiple years to get the bigger features through because of the release schedule of the other browsers. But there's nobody dragging their heels in the sense that they don't want to implement things. It's manpower and schedules. That's about it.
Don't forget personalities and bureaucracies.
Yeah, that's true. I think WebAssembly has been blessed in that it's attracted the kind of personalities who want to work together to move stuff forward. So we've been very fortunate there. So there hasn't been a lot of shouting at any of our meetings. So I hope that can continue in the future.
What's the process for adding new things to the standard, and how often do you plan to release new standards?
So there's no sort of set cadence for releasing a new standard. The specification is actually hosted on GitHub, but there's a ratification process in the W3C for specific spec versions. But this sort of living document that is there, which is the spec, can be amended according to a process we set up, which has a few steps. It's basically you make a proposal by forking the repository and you change the spec text, you add tests, you add an implementation in the reference interpreter, and the community votes to advance it to the next stage. Then when there are two implementations, when there's the formalism and it gets specced out, like there's, I can't recall off the top of my head which stage is which, but basically there's 4 stages. And then once that's done, it's in. And then sort of a snapshot of that gets thrown over the wall to the community, to the working group to be standardized as version or such. That's pretty much the process. It's all driven through the community group, pretty much.
Nice. So one more question. If I decide that I want to implement Ruby on WebAssembly, where do I start?
A good place to start would be to take a look at probably want to look at the specification to look at what WebAssembly is, what the target is. And you would maybe want to take a look at an existing Ruby interpreter. I don't know what your background is as far as implementing languages, but you could, for example, take the existing Ruby interpreter and port it. I think it's probably written in C++. You could at least get off the ground there. If you wanted to implement a JIT compiler, then you'd be generating WebAssembly dynamically. So then you could think about making the back end of a JIT compiler that targets WebAssembly. Those would be the steps you would go through.
Cool. Yeah, the MRI implementation is C, but Rubinius is C++, I think. So there are implementations.
Or you could start from scratch in Rust.
Interesting.
So are there any good resources for keeping up on the state of WebAssembly?
Yeah, so on the GitHub, if you go to github.com/WebAssembly, there's a meetings repository, and that's updated every 2 weeks. We have a CG meeting with notes on what's being discussed. And if you look in that GitHub directory, there's repos for all the new proposals. And so you'll see them, like GitHub keeps track of which ones have been updated the most recently. So they just keep popping to the top. So you'll see activities on all the different proposals. It's actually pretty neat. So then and then each of them have issues filed on them. And then if you want to see the state of the different browsers, you can look at their release notes. You can look at their blog posts. So V8 tries to post at least every milestone, which is every 6 weeks. And typically there's something about in WebAssembly in the notes there.
Great. It's interesting how much what you just described is just like what we're doing with the TC39 and keeping track of new features in JavaScript on GitHub. So easy to track that way too. It's a system that works.
All right. Let's go ahead and do some picks. Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Aimee, do you want to start us off with picks?
Sure. Okay, so I have 2. Since Sunday was April Fool's, I'm going to do a warning that this is not true, but it's kind of funny. So if you go to MDN, there is a 418 status code, and I'm a big tea drinker, so somebody pointed this out to me, and I thought it was pretty funny. So I'll put a link to that in the show notes. Maybe you want to give that to somebody next year, store it away. Anyways, so that's my first pick. And then the second pick, this is a super old blog post. Oh my gosh, it's a decade old. But it's from Coding Horror. And Sarah Drasner sent this to someone, to Burke Holland, who sent it to me. But and this is a really short blog post, but he takes like this section of a book called Art and Fear. And basically the premise of this little passage is that there was this clay instructor, and he gave one group of students the task to, they were allowed one implementation, but it had to be like perfect, and like they were judged on whose implementation was better. But they were given all the time in the world to do it. And then this other group, they had a deadline that they had to they had to do one implementation a day, but then they were judged on the quality of their work like a month's time or something like that. Whereas, like I said, the other group had, 1 month, and they didn't have to produce everything. They didn't have to produce something every single day. And at the end, you would think that that group who had like all the time in the world to just get their one thing just right would be the best, but it was actually the inverse. It was that group who kind of iterated on it. So like I said, it's a really short little blog post, and I'm sure that it's going to, this little snippet does a way better job of painting this story than I have, but it's really good. I don't know. I've just been thinking about like, I have a tendency towards like perfection, and, I'm very much a perfectionist, but like, I think like iteration is key. So I don't know. I thought it was really good food for thought. And that's it for me.
Nice. Cory, what are your picks?
So I have two picks. The first is one I came across today, which is the NPM semantic versioning calculator. So, when you're specifying versions in package.json, you can have a caret, you can have a tilde, and you can use greater than and equal than signs. And there's all this different syntax for declaring a range of versions. Well, this calculator lets you type in a package and then put in that jargon, and then it shows all the matching versions. So it shows you very, very clearly the results of your declaration. So really handy. It's like a REPL for figuring out how to declare the versions you want in package.json. So very handy. Then the other thing I came across recently was a tweet by Kent Beck, who was talking about how to get your conference abstract approved. And he said, the purpose of your conference paper is to get your paper from pile A to pile B. You want your abstract in the A pile and out of the B pile. And he said, the sentences are the problem, why the problem is a problem, one startling sentence, and then the implication of that one startling sentence. So those are the 4 keys to writing an abstract that will catch the conference organizer's attention. I liked this little recipe here, and I looked through some of mine, and you can see how I could improve them by using this. So I'll share that in the show notes as well. Those are my picks.
All righty, I'm going to jump in here with some picks. So I went and saw Ready Player One last night, and if you've read the book and you want to go see a movie where the characters have the same names, and generally play the same roles, and they use 1 or 2 of the same plot devices, and otherwise everything's different, then it's a terrific movie.
That's a lot of caveats, Chuck.
In other words, if you've read the book and you go in with too many expectations, you'll walk out of there going, man, they changed that and that. They kind of changed everything. And then you think about it again, and you're like, but it was a decent movie. So anyway, that's kind of where I came from. If you haven't read the book, go see the movie and then read the book, because I loved the book and I wanted to see a movie version of the book, and that wasn't what it was. So anyway, that's one pick. And then another pick, I have videos that I did interviews at NG Atlanta with the speakers and a few other folks. So if you're interested in seeing what kind of the state of Angular is or was a month or 2 ago, definitely go check those out. They're on the devchat.tv YouTube channel. So just
I'm going to have to go look.
devchat.tv/c/devchattv is where all of the devchat.tv videos are at. And you can definitely go check that out. One other thing that I'm working on, it should be out by the time this goes live, is I've decided to do Alexa flash briefings. So if you have an Amazon Echo and you get your news from the Echo and the light's on, so it's actually listening to me because I said the Echo's name. But anyway, you can add the Amazon skill for JavaScript rants is what I'm calling it. They're just going to be 5-minute coverage of something related to JavaScript or programming or careers or something. So we'll be talking about that. I'm also going to put those on YouTube. So I'm just going to talk at my camera. I talk a lot on camera or on mic. But anyway, so yeah, you can definitely check that out, or you can just subscribe to the RSS feed, and I'll have that in the iTunes stores and stuff by the time this goes live. So yeah, I'm going to try and release every day. I may cut it back to 5 days a week. I'm still working out that bit, but you'll get a bunch of those. So yeah, those are my picks. Ben, what are your picks?
I saw an April Fool's joke about how they're going to remove raw pointers from C++, and I thought that was great. And anything American politics would be a pick for me. Because as an American, watching the show from over here is quite interesting.
Oh, man.
But I don't think we should go there.
No, I completely agree with you. It's funny. I talk to people and I'm like, yeah, the Democrats are a total horror show. The problem is the Republicans are also a total horror show. So, yeah, funny stuff. I'm sure you get a kick out of it. All right. Well, Ben, if people want to read your blog or follow you on Twitter or follow your GitHub activity or anything like that, what do they do?
Yeah, you can see me on GitHub. Mostly my contributions are to V8, so you can see my commits in Chromium. You can see I give talks at conferences. You can read my papers. You can send me email. That's pretty much it. I don't tweet. I'm not really plugged into the whole the news sphere these days. Kind of laying low and doing my compiler work.
Cool. Well, thanks for all your work, and say thanks to your colleagues for us.
Thank you.
All right. Well, we'll go ahead and wrap this one up, and we will catch everybody next week.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.